When I first discovered artificial light at night, I didn't think that there would be much of an impact at all, because my background is looking at light levels during the daytime. I thought that as soon as the light gets into the ocean, it will just be attenuated. Artificial light at night is an all-pervasive problem in the terrestrial and in the coastal areas around the globe. We see populations move much more towards the coastline. When you look around the Mediterranean, you can see these ribbon developments that go and fill in the gaps between the different cities. That's where you start to see the impact of artificial light at night most acutely. About 2 million square kilometres of ocean are directly impacted by artificial light at night. The biggest impact is where you reflect the light in the atmosphere and back down into the water. That's what gives the artificial light at night its reach. Now, what does light do in the oceans? What does it dictate? It's things like the cycle of spawning for corals. They're very attuned to the lunar cycle, and what we're effectively doing with things like artificial light at night is that we're infilling that period of darkness that the corals have become used to over millennia to broadcast spawn, and now that's just not happening in certain areas of the globe. The other thing that the light of the moon is used for is by turtles, for example, to navigate their way as hatchlings off beaches and into the ocean. But if we've got lighting in the coastal zone, they're actually going in the wrong direction and away from where they need to go to. Here at PML, we've conducted lots of different experiments about the impacts of artificial light at night in the marine environment.
The ALICE project is a NERC highlight topic project on light pollution. It is called Artificial Light Impacts on Coastal Ecosystems. We have our mussels as the base of the food web, we have the dog whelks, and then we have crabs as a top predator in the coastal environment that will prey on both the dog whelks and the mussels. And what we are able to do by having 3 of them in these experiments is we are able to explore not just the impacts of light pollution on individual species, but also on the inner workings of the coastal food web.
It's kind of a complicated switching system. At high tide, it switches our pumps on and it changes our lights from being really bright to being 60% dimmer. So that accounts for how much light is being lost through the water column, essentially. We can't do it with the water itself because the water isn't deep enough, so we just make the lights dimmer at high tide. And then at low tide, the pumps go off, so all of our tanks drain, so our animals are effectively exposed the way they would be at low tide on the beach, and the lights get brighter. The dog whelks are laying eggs in our system, which is brilliant because that means that they're not so stressed that they're not laying. But what we are finding is that the animals in the really high light treatments are laying far, far fewer eggs than the animals in the control treatments, which are the ones that don't have any artificial light on them at all.
Predator-prey relationships in the marine environment are incredibly important, as you can imagine. The things like camouflage for certain species of snails, for example. As we move much more towards LED lighting, they got much more blue light, and that blue light penetrates deep in the water column. These snails are more unlikely to be able to hide from their predators at night. Where do we go next with all of this? 2 areas I think we need to look at. First of all is actually what's the genetic response of organisms to light? You know, what genes do they express when they're exposed to artificial light, and how does that compare with the natural environment? The other thing is, you know, what's the impact societally upon changing our relationship with, first of all, the nighttime, and then also what our relationship is with the electrified and lit world. This is one problem actually we can start to take some really good concrete steps towards solving. First of all is turn off lights when they're not needed. Also, we can look at changing the spectrum of lighting. We could then start to shade our lighting, so just concentrating it where it needs to be. And then I think we can become much smarter with the way that we use lights, so that they can switch on and off automatically as and when needed in certain areas. Why should we care about artificial light at night? It's one more stressor that we're putting upon the marine environment, but it's actually one stressor that we can really do something about.